As soon as concrete is in contact with the ambient air, it starts reacting with CO2 to form stable phases of calcium carbonate, more commonly called calcite. Actually, calcite is the main phase of limestone, so we could say that carbonation of concrete is like concrete turning back to stone. Concrete is acting as a CO2 sink throughout its service life. Actually, studies have shown that the surface of concrete could store up to 20% of the CO2 emitted during the decarbonation of limestone necessary to produce cement. And when a concrete structure is demolished, concrete is crushed, and therefore more surfaces become in contact with CO2 from the air, and the CO2 capture potential increases. Of course, our industry is very committed in reaching the carbon neutral target set by Europe, and we already know that CO2 capture will be a key point for reaching this neutrality. And carbonation of concrete is one of the easiest ways to capture carbon in a permanent way. It's a natural phenomenon which removes CO2 from the atmosphere as soon as concrete is in contact with air or industrial gas. So it happens almost everywhere, and it can be accelerated. So enhancing this phenomenon by carbonating demolition waste will not only allow to remove more CO2 from the atmosphere, but also ease the use of recycled aggregates in low carbon concrete. FastCarb is a French national project where 22 partners have teamed up to study the acceleration of the carbonation of recycled concrete aggregates. The two main objectives are to study the acceleration of the natural phenomenon of carbonation by using CO2 concentrated gas, such as cement plant exhaust gas, and to improve the quality of the recycled concrete aggregate, because carbonation can decrease the surface porosity of the recycled aggregate. And when you decrease this porosity, then the water absorption becomes closer to that of natural aggregates. FastCarb project has been going on for 2 years now. We've got 2 pilots for carbonation, one in Vica plant in Créchy and one in Lafarge-Holcim plant of Val d'Azergues. We've produced tens of tons of carbonated aggregates, and now concrete studies and mixed design are going on. And hopefully by the end of the year, we will be producing concrete made out of those carbonated aggregates.